In this video, we will see how to obtain matrix M for BCH decoding. So for BCH decoding, there are several steps to follow. In that, first step is you have to obtain the syndromes and matrix M. So few examples we will do to obtain the syndromes and the matrix M. After that, we will go for another steps, and finally we will do one video which combines all these steps. So the reason behind doing the BCH decoding steps in different videos is that you will understand each step very clearly. That's why after that we will combine all these steps in one video. So here they have given you. We already covered encoding part in one video, where we have seen all the steps of BCH encoding. So here the question is, consider 15,7 double error correcting BCH code. So this is a double error correcting BCH code. That means this code has the capacity to correct two errors. But we have to see how many errors are introduced in RX. So with RX, this is your received code word. RX is x9, x8, x6, x5, x4, x cube, x plus 1. So error is in this, and we already know that there are two errors in this. Okay, so you should know, although the capacity is of double error correcting, but it does not mean that the RX will have two errors. It can have one error also. So here the errors are two. That is mentioned in the problem. Here I have not written that. So it is 2. So find error syndromes and matrix M. So the first step in BCH decoding is you have to find the error syndromes and matrix M. So first thing in BCH decoding is that almost university problems will come with n equal to 15. N equal to 15. This is n, this is k. So if n equal to 15, then you have to use Galois field 16. You have to use the elements of Galois field 16. So this is compulsory. Or I can say the same primitive polynomial x4 plus x plus 1 is used to construct the Galois field 16 for the university exam papers. So for Galois field 16, we have already seen with this primitive polynomial how to obtain these values. In one of the video, we have seen how to obtain these values. Otherwise, I will provide the link for that video also. This is very easy. We have seen in Galois field basics that how to obtain all these values. So the 15 is there, so you have to use these values. In some of the problems, they will also give you these values also. Otherwise, they will give you the primitive polynomial x4 plus x plus 1. If they have not given, then you have to assume this. Okay. So this is the preliminary part, or this you should know if they have not mentioned it. After that, how many syndromes are there? So first I just want to tell you that why syndromes are nothing but, so syndrome is nothing but R alpha I. These are the syndromes. R means received code word, alpha raised to I. So you know that received code word Rx is equal to corrected code word plus error. Error means syndrome. This is corrected code word. This is received code word. Now for alpha square, alpha cube, alpha raised to 2tc, for x equal to alpha square, alpha cube, alpha raised to 2tc, gx is equal to 0, because these are the root of generator polynomial of BCH code. Now cx is equal to mx into gx. So cx is equal to 0 for alpha, alpha square, alpha cube, alpha raised to 2tc. That means R alpha equal to alpha square up to alpha raised to 2 tc is equal to s alpha equal to alpha square equal to alpha raised to 2 tc. That means in this equation, if you put x equal to alpha raised to 2 tc, then cx is equal to 0, because cx alpha to alpha raised to 2 tc has the roots also, are the roots of cx. That's why this is 0. Then sx is equal to rx for these values. Rx is equal to sx for x equal to alpha raised to 2 tc. That's why we are finding syndrome with received code word by putting x equal to alpha raised to I, that is alpha square, alpha cube, likewise. So this is very important, because normally we many times by heart that syndrome is nothing but r alpha I. But why? Because sx is equal to rx for alpha square, alpha cube, alpha 2 tc, because for those values corrected code word is equal to 0. Those are the roots. Okay. So how many number of syndromes are there? So, number of syndromes are 2 tc. tc is error correcting capability, so that is double error correcting. So 2 into 2, that is 4. So let us find first syndrome, S1 si, that is S1 is equal to r alpha 1. So S1 is equal to r alpha raised to 1, so r alpha. So in this equation of rx, you have to put x equal to alpha. So alpha 9, alpha 8, alpha 6, alpha 5, alpha 4, alpha cube, alpha plus 1. So instead of x, you have to write here alpha. Now alpha 9 is equal to alpha cube plus alpha. Alpha 8 is alpha square plus 1. Alpha 6 is alpha cube plus alpha square. Alpha 5 is alpha square plus alpha. Alpha 4 is alpha plus 1. Alpha cube is as it is, alpha plus 1. The values start from alpha 4 is equal to alpha plus 1. So here you can see that alpha cube, this alpha cube gets cancelled out, because 1 plus 1 is 0 in binary. Then remaining is alpha cube, then alpha square plus 1. So this alpha square gets cancelled out, this alpha and this alpha gets cancelled out, so remaining is alpha square, then 1 remaining 1 is there. So if you cancelled out similar terms, you will get with alpha cube plus alpha square plus 1. So this gets cancelled out, alpha cube, then alpha cube, then alpha square, then alpha square. This is there, then alpha square, this alpha plus 1, this alpha, this 1, this 1, this alpha, this alpha. So remaining is alpha cube, alpha square plus 1. So S1 is alpha cube plus alpha square plus 1, that is alpha raised to 13. Next, S2. S2 is S1 square, or you can find S2 as R alpha, or S2 is equal to R alpha square. Otherwise you can use this equation, S1 square. S1 is alpha raised to 13 square, so that is alpha raised to 26. So you have to make it in the powers of 15, because alpha 15 is 1. So alpha 15 into alpha 11 is alpha 26. So alpha 15 is 1, so that is equal to alpha 11. Next, S3 is R alpha cube. So alpha cube raised to 9, alpha cube raised to 8, alpha cube raised to 6. This x9, x8, x6. X is alpha cube now. So you have placed x is equal to alpha cube in Rx equation. So 3, 9, 27, 3, 8, 24, 3, 6, 18, 15, 12, 9, 3, 1. Now again 27. So you have to express it in the powers of alpha 15. So alpha 15 into alpha 12 is alpha 27. 15 into 9, Alpha 15 into alpha 9 is 24. 18. Alpha 15 into 3. Alpha 15. 12. 9. Likewise. Once it goes beyond 15, you have to express it in the terms of 15, because alpha raised to 15 is 1. So 27. So alpha 15 into alpha 12. Alpha 15 is 1. So alpha 12. Then alpha 9. Then alpha cube. Then alpha 15 is 1. Here I have written. Then alpha 12. Alpha 9. Alpha cube. And 1. So 12 gets cancelled out here. 9, 3, and 1 plus 1 is also gets cancelled out. So answer is 0. S4 is S2 square. So alpha raised to 11 square, that is alpha raised to 22. So 22 again beyond 15, so alpha 15 into alpha 7. So 15 is 1, so alpha 7. Alpha 15 is 1. So S4 is alpha 7. So matrix M is equal to S1, S2 up to SL. SL is number of errors in Rx. So we know that in Rx, although BCH is of double error correcting code here, but Rx also have 2 errors. So SL is number of errors in Rx. So SL, then S2, S3 up to SL plus 1. It goes up to SL. And last here it comes to S2L minus 1. So you by heart this form. So here L is equal to 2. So M is equal to S1 to S2. L is 2. Then S2, S3. 2L minus 1 is also 3. 2 into 2, 4 minus 1 is 3. So M is alpha 13, S1 is 13, S2 is 11, S2 is 11, S3 is 0. So this is your matrix M. So these are first two steps of BCH decoding. So we will again see one problem with BCH with finding syndromes and matrix M. After that we will see the next steps, so that you will understand each step better.